I can write the recursive rule for a geometric sequence. Here's what you need to know. A geometric sequence is a type of sequence whose pattern is a common ratio. That means we are multiplying or dividing by the same thing every single time. The recursive rule for geometric sequences looks like this. You do not need to memorize it because it is on your formula sheet for the Georgia Milestones exam, but it is good to be familiar with it. A sub n represents the nth term in our sequence, so that just means whatever term you want. R represents the common ratio, which is whatever you are multiplying or dividing by every single time. And then A sub n minus 1 represents the previous term. So whatever term comes before the one you care about is represented by this light blue term right here. Remember that the recursive rule for a sequence depends on a previous term. Here's an example. Write the recursive rule for the sequence 4, 8, 16, 32, and so on. Let's go find the pieces that we need. We're going to need our common ratio. If I look for the pattern, I see that I'm multiplying by 2 every single time. 4 times 2 gives me 8. If I multiply by 2 again, I get 16. Multiply by 2 again, I get 32. That's the pattern of this sequence. My common ratio is 2. Now we're just going to fill in to our recursive rule. A sub n is equal to 2 times the term that comes before it. So for example, the 5th term would be equal to 2 times the 4th term. The 10th term would be equal to 2 times the 9th term. That's the way that you would read this rule right here. Pause and try this one. The only thing you needed to find is that common ratio, so you need to see what you are multiplying by as you move down the line. Your numbers are getting smaller, and remember that it is okay for your common ratio to be a fraction. Fractions mean divide. So when I say that the common ratio is 1/2, that means I'm dividing by 2 every single time I switch terms. 20 divided by 2 is 10. Divided by 2 again is 5. I could also say 20 times 1/2. Half of 20 is 10. Half of 10 is 5, and so on. And we just fill into the recursive rule. The term that we care about is equal to 1/2 times the term that comes before it. Now let's write the explicit rule for a geometric sequence. Remember that the explicit rule is the one that we're going to be using most of the time because it doesn't force us to go back and find all of the terms that come before it. We can just plug straight in for whatever term we want. Here's what you need to know. Geometric sequences have a common ratio, and this is the explicit rule. The term that we care about is equal to the first term times the common ratio raised to the n minus 1 power. N stands for the term position. So for example, if you wanted the 7th term or the 20th term, that would be a number that you plug in right here. When we're leaving it really generic and just writing the rule, we leave the n alone, but that's where you would plug in a specific value if a question's asking you to find a certain term. That's where you plug in the term number. The explicit rule for a geometric sequence is just like our basic form for an exponential function. So if you remember the format from that, your a of t is equal to b, which stands for your initial amount, times 1 plus or minus the rate of change, all raised to the t power. And remember that geometric sequences have an exponential pattern when we graph them. This is why. It's because their equations or their rules are extremely similar in nature. The explicit rule for a sequence does not depend on a previous term, so a lot of times the explicit rule is way, way easier to use. Here's an example. Write the explicit rule for the sequence 4, 8, 16, 32. Let's go find everything that we need. We need our common ratio, which we know is 2, because we're multiplying by 2 every time. We need our first term, which is 4, because that's literally just the first term we see. And now we're ready to fill into our formula. A sub n is equal to 4 times 2 raised to the n minus 1 power. Pause and try this one. You needed to find your common ratio, which we know is 1/2. You also need your first term, which is 20, and then fill into the formula like this. You can also write your common ratio as the decimal 0.5. That would be fine, but 1/2 is also appropriate. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.